Okay, people. Hello, back. Writing the equation of a tangent line, eh? Need point and a slope. So what are we gonna do here? We'll take a look at number 2. All right, take a look at number 2 here. X plus cosine of x. Let me see. Move this space. Get rid of this. All right, so get the derivative. All right, so we can write the equation of the tangent line. All right, so, we can either get the point first or the derivative first. Doesn't matter. All right, so part B on this page, like I said, I believe it's page 20. So the points, right, we'll input 0, right, and then out will come, right, the y value. So if my function here is x plus cosine of x, I'm going to do the f of 0 is going to be 0 plus the cosine of 0. The f of 0 is going to equal 0 plus the cosine of 0 radians. It's going from the unit circle, right, at 0 radians. Right, that point is 1, 0. Cosine is your x, sine is your y at 0 radians, right? So the cosine of 0 is 1. So the f of 0 here is equal to 1. That's your point. Right, that's your x1, that's your y1. Now we get the slope, people, right? Now we go and get the slope. The tangent line, and that involves getting the derivative of the function first. X plus cosine of x, we take the derivative of each term. Derivative of x is 1. Plus the derivative of cosine of x. Derivative of cosine of x is negative sine of x, right? So f prime of x is 1 minus sine of x. Let's get the slope of the tangent line at 0, right? So we'll do f prime of 0. It's going to equal 1 minus the sine of 0. Well, this is good, right? We can go back to the unit circle here. 1 was the cosine value. 0 is going to be the sine value at 0 radians, right? So f prime of 0 is equal to 1. That's your slope. All right, of the tangent line at 0 radians. So we can write the equation now, right? Using the slope and this point in that point slope form. So we're going to do y minus my y1, which is 1, is going to equal my slope, which is 1, multiplied by x minus 0. You can leave it like that if you want. I mean, x minus 0 is x, right? So y minus 1 equals x, you know, if you wanted to. Right? I mean, you could leave it like that, but... Right? X minus 0 is x times 1. Right? I mean, this one's not that hard to get into mx plus b form. Alright, so the equation of the tangent line here would be y equals x plus 1, if you wanted to simplify it. Alrighty. Alright, so let's see here. Let's take a look at the next one. Part C. It says round to the nearest thousandth where necessary. Wonder what that's all about, huh? Alright. At pi over 4 radians. Right, so pi over 4, in for x, out comes, right, the y value. So we'll input pi over 4 into x. Let's see what happens here. We're going to get y to equal pi over 4 squared times the cosine of pi over 4. Cosine pi over 4 radians, 45 degrees. You know, if you need to go back to the table, go ahead and do so. But that's radical 2 over 2 times pi squared over 16 is going to be your y value. So here I would say this would be a nearest thousandth deal, right? Take pi squared times radical 2, you know, over 32. So let's see if I can do this. No. Oh, okay. Let's see. No. Oh, wait, hold on. Whatever. So pi squared. Pi times pi. Pi squared. What was it over? Oh boy, my memory's gone here. 16, right? Pi squared over 16. Times radical 2 over 2. Guess you gotta do it slow. Right, there we go. What's this? I took the wrong one. And what did I do? Oh boy. This is more trouble than what it's worth here, you know? Oh my goodness. Oh boy. So y is going to equal pi squared radical 2 over 32 is my y value, right? Pi squared radical 2. How do I get rid of this? Okay. pi squared radical 2 over 32. Pi squared times radical 2 over 32. So nearest thousandth, right? Tens, hundredths, right? Thousands, 10,000ths, right? So 0.436, tenths, hundredths, thousandths spot. 0.436 to the nearest thousandth. So my point is pi over 4, comma, 0.436. All right. Let's get the slope, right, by getting the derivative. So this is x squared times cosine of x. So my dy dx here that's going to be a product rule. So the first, x squared times the derivative of the second. Derivative of cosine is negative sine x, plus the second, cosine of x, times the derivative of the first, right? 2x here. Dy dx is going to equal negative x squared sine x plus 2x cosine x. We'll put in, so that's my derivative, right? That's f prime of x. So let's put in f prime, right, of pi over 4. This looks like another messy one here. So it's going to be negative, parentheses, right, because we're plugging in for x, pi over 4 squared, sine pi over 4 plus 2 times pi over 4 cosine pi over 4. So remember, right, cosine sine pi over 4, that's 45 degrees, and if you need to go back to the chart here, they're both radical 2 over 2, right? Cosine and sine at pi over 4 radians. All right. All right, so radical 2 over 2 there for the cosine and sine. Pi over 4. So f prime of pi over 4 is going to equal negative. Pi over 4 squared is going to be that, pi squared over 16 again. Sine of pi over 4 we said was radical 2 over 2. 2 times pi over 4. You could do 2 over 4 to 1 over 2 if you want. Will be pi over 2. Cosine pi over 4. Radical 2 over 2. Let me clean this up here a little bit. So f prime pi over 4 will be negative pi squared radical 2 over 32 plus pi radical 2 over 4. So We got pi squared radical 2 over 32 before to be 0.436. So this is going to be negative 0.436. That's a 4. So pi radical 2 over 4. Pi radical 2 divided by 4, 1.107. 1.1107, right, plus 1.1107, added to negative 0.436, added to negative 0.436, and there we go to the nearest thousandth. We'll do 0.675, right? 0.675. 0.675. That's my f prime pi over 4. And that's my slope. All right, we can write the equation of the tangent line now and then be done with this. So y minus my y1, 0.436 will equal, I'm going to need space here. Y minus 0.436 will equal the slope 0.675 multiplied by x minus pi over 4. And there you go. That is the equation of